A simple look at the data in our stateless table shows us that we have 63 records, and all states and provinces listed of importance have values for the state ID field, the state province name field, the region ID field, and the landmass field. Now, when we look at the metadata of this table, what we see is that it has no keys and it has no indexes. So how is this going to affect what we're going to do next? Well, let's take a closer look at this data and notice we have a mistake. Colorado is abbreviated as CO and Connecticut is abbreviated as CO. It allowed that even though Connecticut should have been a CT. There are no key constraints preventing duplicate records from being entered into this table on this field. Another thing you may notice is that when we get down to NH for New Hampshire, we have the entire record listed twice. It's a total duplicate. So it's probably time to scrub this data, and after we scrub the data, we want to make sure we don't allow duplicates in again. Let's fix the CO Colorado Connecticut problem first. Type update state list, and we're going to set the state ID equal to CT, where the state name is currently equal to Connecticut. Let's select this query and then run it. Okay, that fixes one of our two data impurities, but how about the New Hampshire duplicate? How do we get rid of just one of those records? Simply type delete top 1 from state list, where state ID equals NH in single quotes. Run the delete statement. To check to see if we've gotten rid of our duplicates, let's run a select query. We can see that Colorado and Connecticut each have their own state ID. And we only have one New Hampshire. And we're down to 52 records because we got rid of one duplicate record. Okay, let's put a primary key on the state ID field of the stateless table to make sure SQL will not allow any accidental or intentional duplications. Let's type alter table state list add, and we're going to add a constraint, and we'll call it PK for primary key underscore the name of the table, which is state list, underscore the name of the field, which is state ID. What type of constraint is this? It's a primary key, and we'll leave it as clustered. And we will set the state ID field to be in ascending order. Let's run this. And let's expand our tables and take a look to see what we've done. In the Object Explorer in JProCo under the Stateless table, refresh your keys folder, and notice the creation of this new primary key. Also refresh the Indexes folder, and it looks like we have a new index. We have an index named after the primary key, and it says it's clustered. Well, let's see if this really protects us. Let's attempt to update the stateless table, and we're going to try to set Connecticut back to CO. So update stateless and set the ID to CO where the state name is Connecticut. Okay, let's see what happens now. Oh, it won't let you. It says, violation of the primary key. You cannot insert a duplicate key into stateless if they have the same state ID. Okay, so is all well in our stateless table? All right, it looks like Colorado, Connecticut, that's been resolved. That looks good. Oh, wait a minute. The District of Columbia has 68 square miles of landmass. How come it can say negative 68? It looks like a few negative numbers got slipped into there. I don't know exactly how many. Here's another one. So what I'm going to do is say, hey, the numbers are right. They just have a negative in front of them in a few situations. Let's go ahead and update the table to flip the negative back to positive if it's below 0. So we're going to set the landmass equal to the landmass times -1, where the current landmass value happens to be less than 0. Run the update statement. Wow, 4 rows have been updated. In querying the table again, it looks like we have all positive numbers for landmass. Well, it would be easy for somebody to update or insert a new record with a negative number. So we're going to add what's known as a check constraint, and it's going to check to make sure the number is positive before adding it in. Let's write alter table state list, and we're going to add a new constraint, and we'll call this CK for check, state list based off the table name and the landmass field. Now, we're going to check the landmass to make sure that its value is greater than or equal to 0. Run the alter table statement. Commands completed successfully. Now, any DML statement that tries to put negative values in the landmass field should fail. Let's run this update statement that should try to update many landmass values to negative numbers. That statement that causes those negative numbers, it's not going to work with this check constraint in place. So our update statement scrubbed our data and made sure all the numbers were positive, and the check constraint makes sure no new negative numbers can start coming in. Again, let's look at our stateless table. Notice everything's pretty good. Alaska's our biggest state. It's got about 650,000 square miles of landmass. And DC is the smallest. It's only got 68 square miles. Well, let's look at the check constraint that we just made. Let's expand constraints. And notice here is our check constraint. Now this prevents the numbers from getting too small. Okay, well what about a mistake in the other direction? For example, let's say somebody entered the landmass for Alaska, and they had the numbers right, but they entered square meters or square feet instead of square miles accidentally. So they put 65 million square miles. Now, there isn't even 65 million square miles in the whole world, so I'm pretty sure Alaska can't be that big. If you were to run this update statement that puts 65 million landmass value in for Alaska, it will accept it. Is Alaska really bigger than the planet? I don't think so. So let's update this and fix it back to 650,000 miles. And now make our check constraint a little more robust. Type alter table state list, add a constraint, and we'll use the same name, check state list landmass. And wait a minute, don't we already have this one? We won't be able to create this unless we get rid of it first. But let's finish our logic. We will say check landmass has got to be greater than or equal to 0, but it can't be larger than the entire United States, which is just over 2 million. Delete the original CK underscore stateless underscore landmass check constraint and recreate it with this new code. Now, let's go try to make Alaska ridiculously large, and it says, hey, I'm sorry, I checked, and you are not between the acceptable ranges of 0 and 2 million. You've got to enter a valid number. And there we go. It protected our data based on what we specified as the logic in the check constraint. Lab 1.1, Skill Check 1. Create a primary key constraint called PK underscore retired products underscore product ID on the retired products table so that duplicates are prevented from occurring in the product ID field. Make sure the primary key also creates a clustered index. The view of your Object Explorer after doing this should resemble the figure you see here. Skill Check 2. Create a primary key constraint on the ID field of the Human Resources Room Chart table. Make sure the primary key also creates a clustered index. Skill Check 3. Create a check constraint to make sure that the unit discount field of the sales invoice detail table does not allow negative values. Test your constraint by trying to update the unit discount field with a negative value. When you test your code, use the code that you see in the figure here. You should also see the same error message in the figure you see here. Skill Check 4. Create a constraint called CK underscore sales invoice underscore paid date for the sales invoice table which checks to see that the pay date is never earlier than the order date. The pay date can be the same as the order date, or it can be any date subsequent to the order date. Test your code by trying to update a pay date value to occur before the order date on invoice ID 1. Skill check 5. On the management training table, create a check constraint called CK management training _ approved date that only allows approved date values of 1/1/2006 or newer.